Oh, there it is. Alrighty then. So I think this should work alright. So, years back, I've built that kabuki drop mechanism and did a video about it last night. And I figure, why not look at the controller itself that I had built way back when as well. So, lessons learned from this project. I guess the biggest lessons learned were it's critical to figure out the alignment of these pieces and get an accurate trace of the dimensions of this case, including any distortion or warping from the molding process, because polypropylene molds, and then as it cools, if it distorts and warps inwards, you don't get perfectly square edges. Other phenomenon as well, in terms of just getting the alignment right, there's always a draft angle, so assuming that the bottom of this video window is the I guess the bottom of the Pelican case, there's always a slight draft angle to allow it to release from the mold. That draft angle changes, which means that the dimensions at the bottom of the case aren't the same as the dimensions at the top case. Some pretty elementary stuff. File it all under measure twice, cut once. I mean, you can see in some spots here there's, I guess, a little bit of fudge factor applied on the acrylic. So that's one of the lessons. Another lesson learned is I really wish that I had put some of these connectors on the outside of the case using waterproof cover flaps, just to free up some more space on the surface. Using these Harting style connectors is great, but I kind of wish I had connectors that recessed down. So I mean, 50-50 hindsight, especially this one. Like, a lot of real estate on this panel was kind of sacrificed for the sake of building out a system of cables and things that I can use with all my projects, because I use these Harting style connectors on a bunch of other projects, so I have that flexibility to just hook anything up to anything now. Alright, so just diving a little deeper into this. 1 second. Alright. Let's open this thing up. I figure I will opt for. Here we go. I love my Milwaukee M12 screwdriver, because you can set the torque and just kind of forget about it. It just works. It's reliable enough. One of the other lessons learned from this project is it's kind of critical to design your brackets on the sides so that the nuts are truly captive. I had a lot of difficulty with the nuts not actually being captive because they were, I guess, what's the best way to put it? They're held in by the tension on the screw, so as soon as you start to unscrew, there's a chance that the nut falls back down inside, making it kind of difficult to reassemble the whole unit. Alright, so let's look at how this thing's actually constructed. Things that I'd do again, things that I wouldn't do again. And the last one. this. It's already a little hard to get in here fully. Um, just because of the, I guess, constraints on this connector here. I wish I could actually just, like, release or disassemble this, but unfortunately not, I think. So I guess that's lesson number one. If I'm going to have cables like this, I should have made this long enough to kind of just get in here, route this along here. Okay, so what was my design methodology at the time? I have this aluminum backplane with some DIY rubber shock mounts on the frame. It's probably very hard to see from the camera view, especially because it's at an angle now, but there is some degree of compliance to this in all axes. I used a soft rubber polyurethane compound with a, what's the word? Soft rubber polyurethane compound with hex couplers to act as kind of a captive nut embedded in that polyurethane. And what that means is I can bolt this panel down and it has some vibration compliance alongside everything else. Okay, so what else would I do differently? I guess first things first, this fuse, I would have, I kind of looking back at this, I probably would have wanted to put the fuse on the outside, or at the very least put the fuse on this panel so that if it blows, I don't have to open up all of these screws. You'll note that this was built with an Arduino in haste, with just like a little proto shield, but hey, it works just fine, so, you know, don't knock it, right? I have this DIN rail set of, I guess, common bus bars for ground plus V and logic voltage. I really should have labeled these, but I guess I was in a bit of a rush to just get this thing built for the event. This power supply is probably oversized for what is needed, but at the same time, you know, it's better to overrate than undersize. These DIN rail mounted relay and power supplies. This is your 5-volt logic supply. Ideally, I probably should have put some sort of a crowbar circuit. A crowbar circuit is a small circuit where you've got like a TVS or a Zener diode. So above a certain voltage, it becomes conductive. And then that diode is placed across the voltage and ground rail. So in this case, I'd put the crowbar diode or circuit on the output, and as soon as the voltage on this exceeds that, it clamps down on it, and or it just causes something else to fail, like this to go into overcurrent protect mode, instead of sending more than 5 volts to this guy. Because if I sent more than 5 volts to the Arduino, I would blow it and have even more work to do to fix it. Why is it called a crowbar circuit? I think historically, when you threw a crowbar on bus bars and everything blew up, that was your way to shut the machine down or something. I think there's the lore behind it. In terms of these actual brackets, I would have designed it so the nuts slide in from the side. So right now the nuts are held in by gravity this way. If I was to take this bolt and just push down, I would actually push the nut out. So it's held in by friction and a bit of hot glue. Kind of looking back in retrospect, I really should have designed it so the nuts slide in from the side and they can be secured there. But, you know, 50-50 hindsight, this project's already built. The VHB tape actually seems to be doing pretty good because, I mean, even in this bracket, I'm not sure if the camera can see it, but the VHB tape is holding and the bracket's actually delaminated a little bit. But yeah, like the VHB tape provides enough compliance while still being very adhesive. And this is without even using adhesive primer, where you actually use a solvent-based primer to chemically deposit a small amount of like an epoxy or something onto the plastic, as well as cleaning off any oils, greases, and other compounds that might inhibit adhesion. I'm going to do this for the battery bank project using that DeWalt Tough Box. and I'm actually going to use the primer because I'm securing like a 15-pound battery pack into the tough box, and I want to do that without putting any holes into it unnecessarily. Okay, so what else would I do differently? I think I would have, I guess, given myself the flexibility to connectorize some of these. Connectors can get pretty expensive pretty quickly, so, I mean, adding all these extra connectors all over the place might be a bit challenging. I have been wanting to explore a little bit about using automotive style connectors to basically detach a front panel, but I mean not all of these are low voltage connections as well. This PowerCon connector is 120. I guess it goes up. You can put 240 on here if you really wanted to, but I mean this is low or high line AC, which is not going to do well on an automotive connector where it's really designed for 12 volts. But these guys would be, and they, they're cheap enough connectors. They're positive detent, so in theory they would work okay. I just have to order some from AliExpress, I guess. Yeah, so I guess moving the connectors off to the side, putting some waterproof covers on them, making sure that I have enough length in the wiring to actually fully open up the panel, things like that. And I mean, honestly, I should have just designed an adapter, because look at how many signals I'm actually using from here. I could have used a smaller connector and then built an adapter, because the remote unit that I have has like, I think 7 channels, so there's a whole bunch of pins that it uses, and it very validly could take up all of these all these pins in this socket. However, because I don't need them, I could have just built another connector that breaks it down into a smaller Harding connector or anything else. This XLR connector is for an unimplemented feature where there's a DMX module in here, and that DMX module would provide a trigger signal to the system as well. Never got around to implementing it, and then kind of ran out of space to put it in here, so I mean, maybe one day I'll completely rebuild this into something better, but I mean, for now, and all intents and purposes, it just works. Yeah. I guess also in retrospect, I probably would have using the extra space up here, I probably would have wanted to break out some of either the controls or like an instruction page or something here, so it's a little bit more fire and forget, that I can just leave this with stage crew or something, and then they can figure out how to operate it without too much consternation. Yeah. All in all, this project worked out pretty well. I mean, it's been used a couple times. I've used this as a trigger unit for like air cannons, use 24 volt solenoids. I've used this for the Kabuki drop modules. It's just useful. You know what? There's another item that just came to mind. I should have put a USB port here so I can get to the Arduino. And I guess that's a good time to bring up a little tip, if I can find it. I'll bring it a couple of them. Some micro. Here's one. So off of AliExpress, you can get these short little pigtail cables, and they are actually super useful. What this is a USB-B female to USB-B male, and it's always a good idea to have a couple of these. If you're going to build something like this where you've got a microcontroller deep inside, all you need to do is just go and plug this cable in. And unfortunately, I have the wrong direction. This is a 90-degree turn to the right. A 90-degree turn to the left is what I would really need. But if I can just squeeze this in here. Yeah, so now I've got this cable plugged into the Arduino, and I could just panel mount this up onto the panel. So then you can get to the USB programming port from the outside world without having to open this up. So there's a very real possibility that before I put this unit back into storage that I either unmount this and replace it with this guy, or I just drill a new hole and file it into a square shape for this guy and make it such that I can program it from the outside. Maybe I'll finally fix up this finite state machine code in here. But yeah, definitely give yourself a programming port on the outside world so that you can service your project without having to open it back up constantly. That's a big one, honestly. Wish someone told me that before. With the advent of Fusion 360, honestly, when you buy a more premium enclosure or a more premium project box, you can download the CAD model. This is a Pelican knockoff from Princess Auto, which is a Canadian equivalent to Harbor Freight. There's no CAD model available for this, unfortunately. I don't even think Pelican has CAD models available. But look around for suppliers that have CAD models available. Design your full layout. Make sure you have enough room for your cables, your wiring, you know, your cable tray, all the individual components, boards, everything in your layout. If you have enough space for all that and you can lay it out in CAD, it saves you a lot of time when you just go to build the thing. This was built in a pretty big rush because most of the time was spent making the the Kabuki drop modules with the electropermanent magnets, and I just wanted to slap this together in a clean enough manner. Yeah, other than that, I guess retrospectively, maybe use a smaller Arduino, maybe use smaller components, spin up a custom board. I mean, I could have used more than 8 channels of output here, but, you know, I worked with what I had. What else? Yeah, that's about it. I mean, I've got a couple things on mini DIN rail. I've got the full-size DIN rail over here. You know, one day if I decide to update this and upgrade it, I can rip out a lot of these components, put some new ones in, and it's still pretty modular. So I'm pretty happy with that side of the design. I think just the fuse placement, the connector placement, the lack of a USB access port were pretty big ones, and I think that is about it. So until next time, just gotta find my mouse and end the stream. There we go. Peace.